Welcome to Study Loop.
So now we'll work on problem 90 from chapter 1. In this problem, we are told that gold is alloyed with other metals to increase its hardness in making jewelry. So first, part A, we're asked to consider a piece of gold jewelry that weighs 9.85 grams and has a volume of 0.675 centimeters cubed. The jewelry contains only gold and silver, which have densities of 19.3 and 10.5 grams per centimeter cubed, respectively. If the total volume of the jewelry is the sum of the volumes of the gold and silver that it contains, calculate the percentage of gold by mass in the jewelry. So, first let's go ahead and write down the values that were given, which are 9.85 grams is for the jewelry and 0.675 centimeters cubed for the volume of the jewelry. And then we can write down the density of gold as being 19.3 grams per centimeter cubed, and the density of silver as being 10.5 grams per centimeter cubed. So we can go ahead and set up our problem here to solve for the volume or mass of the gold. So first we're going to go for the mass. So we know that density is equal to mass divided by volume. So we can also write this expression as being mass is equal to density times volume. So here we get, using this, we can say 9.85, which is our mass, is equal to the density of the gold times the volume of the gold plus the density of the silver times the volume of the silver. When we combine those two together, we should get the mass of the jewelry. So we can substitute values in here. The density of the gold we know to be 19.3 grams per centimeter cubed. And this is times the volume of the gold. And then we add the density of silver, which is 10.5 grams per centimeter cubed. And then we multiply by the volume of the silver, which we can describe as being the total volume minus the volume of gold. So now we have an expression here with only one variable, which is the volume of gold. So we can solve for the volume of gold by multiplying through here. So we get, let's go ahead and distinguish that we have a new step here. So 9.85 grams is equal to, we have 19.3 grams per centimeter cubed times Vg, volume of gold, plus we multiply 10.5 times 0.675 and we get 7.0875 grams. And then minus 10.5 grams per centimeter cubed times Vg. So now we can subtract 7.0875 from both sides, and we can do 19.3 minus 10.5. When we do that, we get 2.7625 grams is equal to 8.8 grams per centimeter cubed times Vg. And then we calculate the volume of gold as being equal to 0.3139 centimeters cubed. So that's the volume of gold. Now let's open a new page here. Let's rewrite this volume of gold as being 0.3139 centimeters cubed. We know that the density of gold, so we can calculate the mass by multiplying density times volume. So the density is 19.3 grams per centimeter cubed. We multiply that by 0.3139 centimeters cubed, and we get the mass of gold as being equal to 6.058 grams. Now the question asks for the percent mass of gold. So to do that, we simply need to divide gold by the total, which is 9.85 grams, and multiply by 100. And this gives us a value of 61.5% gold. So the second part of this problem asks us, or tells us, the relative amount of gold in an alloy is commonly expressed in units of carats. Pure gold is 24 karat, and the percentage of gold in an alloy is given as a percentage of this value. For example, an alloy that is 50% gold is 12 karat. So we want to state the purity of the gold jewelry in carats. So 24 karat here we can take as being the total, or the maximum, so 100%. So if we multiply 24 carats by our percentage, we should get the carat value. So we have 24 karat, and then we multiply by 0.615, which is our percentage, and we get a value of 14.8 karat gold. And that is the value for the quality of the